Hello, this is Adventurous Man. I've been quite busy and I've been doing a few projects along the hydrogen. I need to catch you guys up, and this is the first one to do just that. Now, this isn't the latest, but this is what I made next, made out of washers, 25mm diameter washers. As you can see, there's quite a few, and very, very small. Now, obviously, there isn't much surface area. So what I did to make up for it is put in a whole lot of alternating single cells, just like you see in a battery basically. And those bits sticking out, gold and black ones, they're the ones, they carry the current, the positive and negative sides of each of the different parts within there. Now, so that made up part for surface area, but obviously not by much. The real big thing about this is the spacing in between. It is extremely small. None of this 3 or 1.5mm spacings. We're probably talking more closer to 0.2mm spacing. Now, what I made it out of is this plastic here. Snap lock bag that you get from a bank or parts stores when they sell you small parts and stuff like that. Found out if you put it in boiling water, this doesn't shrink or anything at all. It's quite nice. It's quite good. I don't know exactly how it reacts in the potassium hydroxide, which is what I use, but it seems to be perfectly fine. I've had this cell running for up to about 20 hours and no problems so far. It's quite impressive. Okay, now originally, well. No, we'll start this way. This one here has been hole punched out. 2 different sizes, just under 14mm outside diameter, inside diameter just under 6mm. Works beautifully fine. And as you see, there's quite some thickness there. That's because there's about 14 of them in just that little package there. Beautiful. I was able to do a whole lot together at once, enough to last me for quite some time, hopefully. Especially since I want to be making several of these cells eventually anyway. But originally, how I made them? By using this. I made drew out a whole lot of circles on the bag, cut them out with the snips, the outside diameter, started with that and ended up with a whole lot of circles. Now the problem I had was forming the inside circle, which is obviously a lot smaller and therefore a lot harder to make. Once again I did it with snips. Now how I managed to do it after about an hour or so thinking about it, so basically folded up these round circles again. So I folded it 3 times, but effectively halving it each time, and then I cut the very tip of the triangle off. This left me with not a round hole but a octagonal type hole, and it did the job very well, as I'm telling you. This works very well indeed. I will eventually show you. I'm just trying to catch you up at this stage. So, that is the spaces. Now, with such thin spacings, any difference or inaccuracies with how flat the surfaces are matters a great deal. I found out these washers aren't actually flat. Due to the way that they're produced, which is they stamp them out, it has a round edge and a flat edge, and the flat edge there, well, let's just say it's not flat, the whole thing's actually slightly curved like that, especially at the ends. So I had to match these up. Once I'd done that, I had no problems whatsoever. So I made up a whole lot. This is the anode or negative side, that's the cathode or positive side. Now the interesting thing about this, and I don't know if you can see, in fact I'm sure you can, there are 2 colours there. There's black and, well, I like to say gold, but it's actually bronze. I reckon it looks quite classy. This is after being working in the potassium hydroxide and distilled water for up to about 20 hours I guess. Quite nice. The water, after that, slightly discoloured as you can see, but no problems whatsoever with sludge or anything else like that, only a slight discoloration. Very nice indeed. So so obviously I'm going to keep working with this. Now, when I finally hooked this up to my to my battery, which was also on the charger, so I was running about 13.8 volts approximately, the current went off the scale. It was quite interesting, especially since I ended up with things like hot wires and stuff like that. It was most exciting and very perplexing. So I had just purchased myself a shunt to put on my car eventually. I put that across and put the voltmeter across it, as you do with shunts. I found out that at 14 degrees Celsius, at about 13.8 volts, across that little cell there, which incidentally is not even 70 millimeters across, I was pulling somewhere between 63 to 67 amps. That is huge! Unbelievable. So I wanted to get this thing working and test it out and stuff like that, have it go and see what happened. But obviously I couldn't do it at 63 amps. I just didn't have the power supply to do it. I needed to bring the amps down. Now I don't have a voltage divider or a resistor powerful enough for current, a way of controlling the current. Well, that's what I originally thought anyway. And then I got this. I put the cell at one end of the container, hooked up the negative there, and left the positive side free floating. Essentially, just like you do with, so that's the negative there, that's the positive. Essentially, just what you end up with the positive being floating or neutral cell. Then I energized this, made this the cathode, and put it into the water this end here, not even touching. And then I moved it back and forth, and I've noticed that the current was changing pretty well much as I theorized and what you'd expect. This incidentally proves that there is resistance, and it is dependent on distance as well as temperature, as you'd expect with anything else. Anyway, I found that when I had it up close and I had the current going through here at about 8 amps, the voltage drop across the cell was about, let's see, I said 8 amps, was about 2.1 volts. When I had this right across, virtually touching the side there, the current ended up being about 4 amps, which is as low as I could get at the time, and the voltage across it was 1.9 amps. Very interesting stuff. Eventually, what I want to do is try different currents and find out what the current and voltage curves are for this little sucker. Anyway, so, incidentally, this is distilled water with potassium hydroxide, 50 grams potassium hydroxide to a litre of water. Anyway, I put it in there, had it running for 8 hours and then 10 hours straight. Started off at 4 amps, which is 1.9 volts across. Both times got as hot as high as 68 degrees Celsius, and the voltage across here is about 2.1 and 8 amps, as you'd expect at that voltage. So, very sexy stuff. So I'll be working with this some more, and I am very interested to find out what the gas output will be. Now I also suspect that a lot of that current is due to leakage as well, so I'll be working with that as well, leakage current, because there's a lot of exposed surfaces there, which will also, as I was running it, we're producing gases as well. Anyway, this is Adventurous Man signing off. I'll be making other videos to catch up to where I am at the moment. Catch you later.